is the basic meaning of inheritance? Inheritance allows one class, the derived class, to inherit properties and behavior from another class, which is known as the base class. Like this is a base class.
Mm-hmm.
You're able to see my screen, right?
Yes, yes, I can see.
Okay. So base class and the derived class inherit the properties. So this is the derived class. Derived class. Okay. And then enables the code reusability and hierarchy creation. Okay. Like
Mm-hmm.
whatever is not we do not write like redundant code again and again. We just reuse that code, which help inheritance and helps in that way. Now, what is the syntax? How we write the syntax? We will discuss today. Like the class, which is you want to write the derived class name. Access specifier, we already talked about it. Like there are three types of access specifier. There's public,
Okay.
protected, and one is private. There are three types of access specifier. Like how we can inherit. Like it is slightly different. Like what we discussed in access specifier. The terms are similar, but how they work, I will tell you. So access
Okay.
specifier, they are public, protected, private, and the base class. You from where you are deriving. From where you are deriving the like you are deriving from. Basically, this is the base class. This is the new class you want to write, and the body of whatever you want to write. And the access specifier, like we already talked, I told you, like public, private, or protected. Let's try to understand what, first of all, like what this public specifier, access specifier mean here. Like, what's the difference? See, what happens is, like suppose there are three modes. I can inherit the class. There is one mode is public. Publicly, I can inherit. One mode is uh,
Mm-hmm.
protected, and basically one mode is private.
Okay. Okay.
If I inherit the class publicly, which means all members, which are, try to understand, this is slightly a different thing, which are public
Okay.
in the base class will be public. Two derived class
Okay.
also will be public when derived also. And whatever will be private. Private remains private. Unprotected remains protected. Means public means as it is. Like whatever is the specifier in the derived class, which will be copied in the base class, which will be copied in the derived class as well. Protected will be protected.
Okay.
I will give you an example to understand it better.
Okay. Sure. Sure.
This protected means like all members which are public
Okay. Okay.
and protected will be protected. Will be protected. And private will be private.
Okay.
Like suppose I am deriving a public member of a base class. If I what if I use in the derived class, and if it is the mode is protected, and then won't be public anymore, it will be protected. You got it right? Like that means I can't
Yeah.
access. If I create an object of this class, the derived class, and I call the member the from the main function, can't call it because it's not no more public, it becomes protected. That is the difference. So private becomes private. And the third thing is private means all members are private. All members private, like whatever is the type of in the base class doesn't matter, all members becomes private.
Okay. Okay.
This is the like how we inherit. That also matters, like publicly we inherit, protectedly types of how we inherit. How we inherit. Let's try to see in the code part this thing. Like this is how we write it, and this is how the access specified. Let's try to understand. Class derived. So five. Space STD. Let's suppose, let's try to take an example of again that uh, vehicle class only, vehicle class and bicycle class, something like that. So, yeah, let's try to take an example of. Let's try to make a base class as vehicle class. Class is vehicle, and suppose like I made a public member here. I make a public member
Mm-hmm.
and a public member. Like let's say speed. Let's say it's a speed. Speed is public, and let's say protected member as let's say speed, or you can say kept like mileage or like whatever, like speed away and price, you can say price. So basically this is my base class. Let's try to derive it. Now there can be many type of vehicles. So let's say a car is one of kind of vehicle, right? So a car is a derived class of a vehicle. So
Okay.
class, we need to write the name of the class, like whatever it is, the name of the class, and how we inherit it, like publicly, and like here I show you, right? This one, this is the syntax. Like first of all, the class, the derived class name, colon, and then which type, how you want to inherit, public, protected, or private keyword you have to write, and then the base class from where you are inheriting. So yeah, car, and like, let's suppose I am inheriting publicly. So public, and which class from where I am inheriting? So vehicle. So yeah, fair enough. So yeah, like again write the colon, and let's try to see like how can I exit it. Now this is how I inherited it, and let's try out. If I want to read the speed I can use, so I can easily use it. Check it.
Okay.
And
Okay. Yep.
oh yeah, yeah. Think it comes. Wait just a second. See out. Okay. This calculation has no storage class. Okay. This thing happen or what? Just a second. It should not happen. Um, count. Uh, this declaration is no storage class or type data specifier. I'm not sure what is happening. Let's see. Wait. So yeah,
Yeah.
we can exit it here. Speed and okay, price. Let's try to see and creating an example. Okay, let's given a speed for 1,000 here and price as whatever, like 50. We're giving. We want, and I will make an object of not the base class as a derived class. I will make the object. So let's say car C. I will make. And can I now exit the speed? Let's try to see C dot speed. I can easily access it, and let's say set it to, maybe I change it 500, 5,000, and let's try to print it. Count C.
Okay. Okay.
Let's try to print the object, and let's try to create an object of that also. Okay, object base class C dot speed. We already made it, and we are able to change it, right? Now let's try to change. Can we change the price? Let's try to see that. C dot, no, we see it will show which are accessible. So it's only showing speed, right? We can't change the
Yep.
price. Like it will show error because it's a protected one. And protected means I can use it here, but I can't use in the main function. Okay.
Okay. Okay.
But this happens because I have inherited publicly. Let's suppose I have inherited protectedly. What happens then? Protected. Am I able to do the speed or not? Let's see. Now speed becomes also inaccessible. Why? Because I have inherited protectedly. Now our public member and protected member also become protected. Means like they can be used in the hierarchy cycle, but I can't use in the main function. It is the speed is no more public here.
Okay. Okay.
Here it is public. Like if I made a vehicle,
Yeah.
vehicle object, right? Here it will be public. V and V dot speed. Yeah, I can access it here, but I can't access from the derived class. You got the difference, right?
Okay. Yes.
Okay, so this is like how we inherited. Let's suppose it is uh, protected, it's fine. Like I can use it here. Let's suppose if it is private,
Mm-hmm.
all members becomes private, I can't use it there also. Let's say I inherited privately means all the members becomes private. Let's try to, can I use it here? Let's try to see. Let's say speed as I want to. If this is this and yeah, let's try to make an object again. Car object, car C and C dot speed I can use like, but this type is it's become it's no more protected. It becomes private. Okay, the this speed here is public, but here it is private, and this protected price also becomes private. So this is how it works, and yeah, this is the basic example. Let's try to move it forward. So yeah, like now the comes like how many types of inheritance is are there? Like there are type of single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. Mainly we are concerned with like single, multiple, and multi-level. These are like okay are like one of the types of derived from this only, right? So let's try to understand whatever we are discussing till now. Like vehicle is there, vehicle we are deriving like car. So this is a single level inheritance. Like it's not there's only one level from vehicle car is deriving. So single level
Okay. Okay.
inheritance. And the other type of inheritance, like there are multiple inheritance. Multiple inheritance means suppose there are class A and there is class B, and from both of them, let's suppose this is father and this is mother,
Mm-hmm.
and the child is derived from both, right? The child is
Yeah.
so this is like a multiple inheritance. Multiple inheritance. And there are many more, like suppose there is like something known as multi-level inheritance. What's the difference between multiple and multi-level? Multi-level means your generations, right? Like your grandfather is there, your father, then you child, then child becomes grandchild, also have son, so basically grandchild, something like that.
Yeah.
So this is known
Okay.
as
Okay.
you are inheriting all of them, right? So this is known as
Yes.
multi-level inheritance.
Okay. Okay.
Multi, multi-level inheritance. So this is a like multiple we can inherit and we can implement in way as well. And hierarchical is like a tree structure. Like there is a combined of both things. Like suppose A is a class and B is derived from A, then C is derived, and then it has combined of multiple and multi-level both. Like you understood, right? This is like family, pura free, full family structure. So like A is our one of the you can say the ancestor class, ancestors, and then this is a family. They derived, then it is a mixture of both multi-level and multiple inheritance. Mixture of multi-level and multiple inheritance. Basically, this becomes a hierarchical inheritance. Spelling hierarchical inheritance. You just need to know these terms. The three important things are this one. These like one, two, or three are very important. You have to understand what are someone can ask you. This is just you should know the term. Okay, what is this and how to. No one will tell you to implement it. These three are important. Like how it works, multi-level, this and this. Yeah. So
Okay. Okay.
single inheritance, we already see them like, oh wait, we have already seen the list. This is a class we defined, like the A is suppose the vehicle class we defined, and then like the class B is public A, we already use that car as a car we did. The whatever we have done till now, this is single inheritance section. And then
Okay.
we have discussed already about public, private, and protected inheritance modes. Public members of base class remain accessible in the derived class. Private base class member become private in derived class, and protected base class members are protected in the derived class. We already talked about that. Like what is the table? Like I can quickly make the table as well, so you can just quickly understand it. So like there is a 3 cross 3 table basically. What is the mode and what becomes? Basically, let's suppose the mode is public, mode is protected, and mode is private. And this is like mode. This is like member. What is the type of the member? So basically, here it is public, protected, and it is private here. After applying the public mode, it will be public only. This will be protected only, and this will be private only.
No,
In the
okay,
protected
okay.
mode, public also becomes protected, protected remains protected, and private remains private.
No,
And
okay, okay.
in private all becomes private. This is the table you should keep in mind. Okay, right. Yeah. So this is how it works. Multiple inheritance, like we let's suppose class A is there. Like suppose the father child. Let's try to see code also. Like suppose this is a class A we define, and the class B we define, and now the class C, which is derived from both class A and class B. Every time you have to specify how you are inheriting, like which mode, publicly or privately. Public A, comma public B. Let's try to see the implementation also. So this is one of the example. Let's suppose I write two classes, father and mother. Father, let's say maybe color. I'm not sure. I should not say color. Age. I could say age. Yeah. Height. You can say like height. It will be easier. Height and color. You can say height, color.
No, okay, okay.
So let's take average of both of them. Like height. Suppose it's 20. Color. It's like whatever. It's 4. Whatever. Like 8 and same things are there in the mother as well. So mother, oh sorry, this is fine. Let's say height is 40, color is something 5. So now let's say this is mother. And now the child is derived from both of them. So class child is deriving first of all the father. How he is deriving? Let's say publicly is deriving publicly, and father, comma. Then again you have to specify the specify public or whatever you want to specify, and then
Yeah,
mother.
yeah.
So mother, and then yeah. So this is how it works. And suppose you want to know the age, and so his height, uh, the mother height, and it says height should say height. You should specify. It would be different for him, right? So color mother, yeah. So yeah. So let's suppose I want to know the height of the child. So let's define his height as h.
Centimeters or feet?
Yeah, like whatever. In like we are just doing in term like relatively, like whatever in numbers I'm
Mm,
playing. And let's now,
okay.
if you want to know the height of the child, so I'm making a formula average of father and mother. Okay,
Yes.
h is equals to like height of father is height. Wait, just a second. Height like okay, height of father is this, publicly we inherit is this, and we are able to do that. Height, okay, height. Wait, just a second. Publicly we should write, right? Let's suppose I should write publicly we should here because that becomes private here actually. So I'm not able to use
Yes.
it. You right? Got it right?
Yeah.
Because by default they're private, so that's why it's not showing me. So h is equals to height, height of. Now I can easily access it because see in the classes also I need at least protected,
Mm-hmm.
right? If I do it
Yeah.
protected, that also is fine because I can use it in because I'm using in the class only, like in the hierarchical terms only. I'm not using here main. I'm using in the derived class only. So it should be at least protected. So I can use it.
Yes.
So h is equals to height of father plus height of mother, and let's say it should be divided by 2. It's average of both of them, and then what happens? But here it's like it's just a second. And h. So basically, we have derived right, the height and okay, fine. And then let's suppose color as well. Similarly, C is equals to
Mm-hmm.
average of both color plus color n by 2. Mm, mm, mm. Now I just need to want to know the color of the boy and whatever. Let's make an object child ch and just count. Oh, child is small. Look, my child is small. And ch dot like whatever he has. He can like we can know the color of the mother also from here. Color of the father
Yeah.
as well. Okay, I didn't make it public. That's why it's happening. So yeah, make it public as well. Public. Yeah, not able to use that. Yeah, to ch dot. Now I can make. So yeah, like it's showing the color of him, color of his height, color of mother, everything I can do everything. Like we can inherit it publicly, right? That's why I can use it
Yeah.
anywhere. Yeah, like it will give me the average or whatever it is. Like color, I think it's 4. It's giving me 4, maybe 4 plus 5. Yeah, like 9 by 2 is 4, right? Okay. So that's how
Yes.
we can multiple inheritance it is. And now the key takeaway, like this is the basics of inheritance. You should keep in mind, like what is its use case, its use help in the code reusability and the logical structure because it makes sense, right? How we are like deriving the properties and we are using it our codes so it becomes readable as well as becomes logical as well. And the multiple inheritance don't need worry about virtual now. It's not important here and add complexity but offer flexibility also and other appropriate use of inheritance in different scenarios like which type of inheritance you want to use you have to be careful like which single inheritance multiple so it depends upon the case which you want to use okay fine till here
Okay. Okay. Yeah.
so I am thinking I should cover inheritance because I have slides today will it be fine for you
Yeah. Yeah. Sure. Sure. That's fine.
okay just a second So basically, because the first starting is happen with encapsulation also in encapsulation only like there are actually 4 pillars. If you're aware or not aware, there are actually oops are there are 4 pillars of oops. This is very important. First is encapsulation. Encapsulation. One is like we already talked about inheritance.
Yep.
Order is like that only, but it doesn't matter. But still, like generally, in encapsulation is first taught, then inheritance, then polymorphism, polymorphism, and the last is abstraction.
Okay. Okay.
Abstraction. So yeah, this is how it goes. Then let's try. We have talked about inheritance. Let's try to talk about what is encapsulation. So yeah, encapsulation. So what is the literal meaning of encapsulation? Like encapsulation, let's start with an example only. Like suppose there is an count section in a company
Yep.
and there is a sales section, you can say sales section. and somehow they are both they have their own data. They have their own data,
Yeah.
and but sometimes like they require their data. Like suppose account section required sales data, and sales sections required account to manage their data. Okay, right? So both need their
Yeah.
data at some point of time. Now, sub I want like someone should go to a manager of salesperson, right? Manager of sales section, and then only he will give the data of sales section, right? This is how it should work. It should not happen this way directly. Data, uh, getting data actually to say. Like suppose if they have access, they can directly access the sales section data without the manager. It will be like very chaotic, right? So there
Yeah.
should be some mechanism. There should be some manager or some middle person who will handle the data from who will, if account section asks some data, the sales section manager will provide the data. This is how what is the literal meaning of encapsulation. Like there is suppose a finance section, account section, different sections are there, and the similarly they do records of keep of various things. Now they arise a situation for some reason an official from finance section need all data about the sale in a particular month. In that case, he's not allowed to directly access the data of the sales section. He will have to first request and contact some of the officer in the sales section, and then he will give the particular data. This is what encapsulation is. The data of the sales section and the employees get manipulate are wrapped under a single name sales section. What that means is like this help in like security of data. Security of data
Hmm.
means the data is not manipulated. Also, data did not get manipulated. Data is not getting manipulated. Like, but also it helps the data in control as well. Menu
Okay.
created, whatever. Yeah. This is the little meaning of encapsulation. Let's try to jump on. Is a if the formal definition is like that. Encapsulation is a bundling of data of various variable and methods. Like actual where the OOPS starts, right? Like whatever talking about the fundamentals of OOPS, why we need that is due to encapsulation only. Is the bundling of the data and various methods, functions we are defining, right, for a particular class that operate on a data in a single unit. Like a person or a vehicle, like it has various methods and variables, right? So if the combinedly it operate in a single unit, it occurs in a single unit typically. That is a class. It is used with implemented with the help of a class. And the
Okay.
purpose,
Okay.
what is the purpose of encapsulation? Obviously, the restricting the direct access of to some of the objects component to prevent the unintended interference. Like you're this is we are already discussing the access modifiers, right? Like we need some different access modifiers to access the data, like public, protected, and private. Encapsulation is implemented with the help of these access modifiers only. Like we have the access, what data we need to show, what data we don't need to show publicly, privately, or protect. So this is how
Okay.
encapsulation
Okay.
is implemented using access modifiers. Access modifiers. In literal terms, just if you don't understand anything, like encapsulation is thing like you have the data, you combine in one form, like in bundle in one unit and use it. And then you have the you have the right to how to give access. You want to give privately access, public access, and protected access. You have that control over the data. That is how encapsulation is, what it means.
Okay. Okay.
We have consider an example as well. Like what are the three key features I want to talk about the encapsulation? Information hiding. Like whatever information it should not be publicly available. Whatever we want to show, we will show, and what we don't want to show, we won't show. And information hiding, data protection, and separation of concerns. Like this is a bit of what we have discussed till now. And like this is we I think in the first class only we discussed, but still like how this is comes under encapsulation. Like suppose an employee have a salary. I already told you we should not access directly salary. It should not happen like that. We should
Yeah.
there are public functions like set salary or get salary. So that methods we should getting the salary or like let's say updating the salary. So there should be some mechanism like that. This the working of these is encapsulation. This is how encapsulation is. Encapsulation.
Okay, okay.
Like whatever the basics of hoops is like encapsulated is named as encapsulation. So like what is the benefits of that? Yeah, obviously the data security, access control, we have the control over the data, enhance the code maintenance of as well and readability. This is the like you can apply it anywhere. Like this is a fundamental of hoops. Fundamental of all four pillars. Fundamental of all four pillars. Four pillars of hoops. The code maintenance. That's why we are using oops, right? Because we want to maintain the data very, and so that we can easily read it also. Someone else also can easily read it. And allows validation through getters and setter methods. Like already told you to, yeah, we can instead of going directly to changing the member, we have to go through the methods, public methods to change the data. And
Okay, okay.
as we already discussed, the access modifiers, public, private, and protected, accessible from outside of the class, private, accessible only within the class, unprotected within the class and by the derived classes. And encapsulation is also
Okay,
known
okay.
as abstraction also. Now, like this is uh, a bit of confusion. Like abstraction, if I just told you, there's a term also known as abstraction. Like this is also one of the four pillars. Abstraction. What it means now. Abstraction is hiding the implementation details. We'll talk about in later also. Like I'm giving a brief idea. Hiding the implementation details. Implementation details. This is closely resembles with the encapsulation. In encapsulation also, we don't want to show the data, much data, but here the implementation we want to hide. Like suppose there is a sort function in C++, sort vector yeah, array, okay, arr dot begin,
Yep.
something like that, and arr dot end. Now we should not the user who is using it is not required how it is working internally. He just want the output of that sort. He wanted the sorted array. He don't want which algorithm is internally implemented and how much time is taking. We don't want that. So that's why here the abstraction comes into the picture, hiding the implementation details. We don't want what we want. We first just want the output. So that's why it is abstraction. So this there's a bit of confusion always between what is encapsulation and what is the difference between abstraction. See, the encapsulation is hiding the internal state, allow controlled access. Like we also want to hide data also here, but not the implementation wise, like due to security reasons. That's why we want to hide the data here. And here the we want to hide the data because of hiding the complexity of the data and showing only the relevant information, because if we show the unnecessary information it's not relevant for the user, right? That's what
Yep.
is abstraction. Encapsulation, actually literally we want to hide the data because of the security reasons, because of the security reasons hide the data. Like this is a very important question. It like I think it can make it's like very confusing to hide the data due to security reason, due to security reasons, security reasons. And if I want to
Okay,
talk
okay.
about this, like hide the implementation details, hide the implementation details due to higher complexity. Like it's not like I want to hide it, some it's security reason. It's like yeah, like suppose I give you so much something irrelevant information in front of what you will do with that? Nothing, right? Why you want to show that? Implementation details due to higher complexity. Due to
Okay, okay.
higher complexity. Yeah, so this is how encapsulation works. Abstraction, yeah. What are the like advantage of encapsulation? Like in I think I told many times, like security, obviously. we are controlling the data, so yeah, prevent unauthorized access. Like we know which what is private, what is protected, and how we are controlling our data. Flexibility, yes, like can change the implementation without changing the interface. Like obviously there's the flexibility in data and modularity, the clean separation between data and behavior. Like this, we know how. Like again, I this is the 2 points are like you can use in any pillar of the hoops. It's a modular, it's clean, it's readable. So yeah, something like that. So yeah, let's try to understand with an example of classes how we can implement the encapsulation on a part. Encapsulation, this is like I think we already took an example. Let's try to think take okay. Like this, I created an account class and privately
Hmm.
I declared account balance because I don't want anyone to see my account balance. And publicly I declared the matter. Like anyone can deposit in my account, right? Like I
Yep.
if I send you and give my ATM card, you can also deposit it. But you can know my balance if I you have that ATM card because I give you an access, right? If I don't give
Yes.
that card, you can't see my account balance. So yeah, that's how
Yeah.
deposit
So
account.
the basically it's like a entrance in a sense, the key.
Yeah, exactly. Yeah, exactly. The lock and key also. That's fine. Like if you put a lock, I have given you the access, the key to
Hmm.
open that lock. If you don't have that key, you can't open it. Something like that.
Yes.
So this is like deposit. Yeah, I give you this deposit function. This is publicly this and withdraw. This is also main public and get balance. I can just call this get balance function and I can get the balance of my account. So the conclusion is this finally encapsulation is the key to protecting the data, key protecting the data and promoting the modular and maintainable code, proper access control, public private protected, ensure that class data is correctly used. So yeah, this is like bit of the encapsulation part, and this is inheritance part.